Hello everyone, in this video we're going to talk about two tangent theorems with circles. The first one we see is called the tangent line to circle theorem. And the big idea here is we see this right angle box. So if we have line A here, okay, it is tangent to circle B if we're going to say line A is perpendicular to the radius, which in this case would be BC, okay? So that's our tangent line to circle theorem. Next one we're going to talk about is the external tangent congruence theorem, which basically says segment BC is congruent to segment DC, right? So as long as BC and DC are tangent lines, so that's probably going to be given to you in the problem, then we can say that those two segments there, BC and DC, are congruent, okay? So let's look at some examples where we solve some problems, find some missing measures associated with these two theorems. So example number one, it just asks us, is line or is segment BC tangent to circle A? So here, remember, if this is tangent, then this needs to be a right angle. So all we need to do is check these three numbers by using the converse of the Pythagorean theorem. So we're just going to plug these numbers into a squared plus b squared equals c squared. And if we get a true equation, then we know, yes, this is a right triangle, which means segment BC is in fact tangent to our circle, okay? So here, let's say 12 squared plus 35 squared equals 37 squared. So I know 12 squared is 144, and let's type in 35 squared, and we get 1,225, and 37 squared gives us 1,369. So now when we add 1,225 to 144, we do get 1,369. So since that's true, we're going to say, yes, segment BC is tangent to circle A. All right, now let's look at B. We have 24, 44, and 51 as our side lengths. So we're going to do the same thing. We're going to say a squared plus b squared equals c squared. And let's plug in 24 for A, 44 for B, and 51 for C. So 24 squared, 44 squared, and 51 squared. So this gives us 576 plus 1,936 and equal to 2,601. So if we do 1,936 plus 576, we get 2,512, okay? So these are not equal to each other. So now we're going to say no, segment BC is not perpendicular. So therefore, this is not a right triangle, and therefore, segment BC is not a tangent line to circle A. All right, example 2 tells us point C is a point of tangency. Find the radius of circle A. So now they're already telling us that BC is a tangent line. So we need to use the Pythagorean theorem, plug in what we're given to find the radius of our circle. So if we use a squared plus b squared equals c squared, let's let A be r right here. B would be 36, and c is going to have to be 24 plus r squared, okay? Now we can simplify here a little bit. 36 squared would be 1,296. And on the right side over here, this is actually the square of a binomial we talked about in Algebra 1. So we can multiply this out as r squared plus 48r plus 24 squared, which is 576. Now we just need to solve for r. Well, if you notice, we have an r squared on both sides. So we can subtract those, and those r squareds will cancel. Now we have 1,296 is equal to 48r plus 576. So let's subtract 576 from both sides. And when we do that, 1,296 minus 576, we get 720 equals 48r. And last step, we can divide both sides by 48, and we get r is equal to 15. Okay, so our radius there would be 15. All right, last example. Now this is involving our external tangent congruence theorem, and it says segment BC is tangent to circle A at point B, and segment DC is tangent to circle A at point D. Find the value of x. So as long as we remember this theorem, we know that these two segments, since both of these segments are tangent, then we can just set them equal to each other because they should be congruent. So we're going to say 7x minus 23 equals 61. We will add 23 to both sides, so we get 7x equals 84. And we'll divide both sides by 7 to get a final answer of x equals 12. Okay, so that is the tangent line to circle theorem and the external tangent congruence.